In this video, you're going to learn how to draw a molecule by looking at the name. And you use basically the same process, but just in reverse. So the example that they've given you here is 1,3-pentadiene. So we got a couple of things going on. You know that you have a penta chain. We have an ene ending, but it's also telling us that we have a diene, so we have two of those enes. So what we need to do is we need to break it down. We're going to use the same process that we've used before. We're going to start with the parent chain, and our parent chain has a penta name, so that tells me it's 5 carbons long. Okay, and that we have some numbers. And we're going to, our previous examples, we would be numbering in order to have the branches or the double bonds, whatnot, on the lowest numbered carbon. So in this case, I'm going to go ahead and go left to right. And I know that on carbon 1 and carbon 3, I have an ene, which is a double bond. So on touching carbon 1 and touching carbon 3, I have a double bond. There is nothing else in this structure given to me. There's no chloros, there's no methyls, there's no other carbon groups, there's no other branches. We're just being told that at carbon 1 and carbon 3 we have a double bond. So we would finish filling this in to make it so that carbon has 4 bonds touching it. We'd finish filling it in with with hydrogens. So we'd have a hydrogen here, here, and here for that first carbon. We already have 3 bonds on this carbon number 4, so we're going to add 1 more hydrogen. There we go. Carbon number 3 has 3 bonds on it, so we're going to add 1 more hydrogen. Carbon number 2, same situation. And carbon number 1 needs 2 more bonds. So where you decide to put them is up to you, but you need to add 2 more hydrogens. So if we were looking at the full out structural formula of 1,3-pentadiene, this is what it looks like. If we were doing the condensed structure, we're going to have CH2. We're going to show that double bond to a CH. Then we're going to have a CH again, and another double bond with a CH, and then our last CH3. Sometimes, some places, I'm going to have to write this on the top, they would condense these even further and have CH3 double bond to CH twice with a double bond CH3. I don't know that this version up here is saving us much, but it's a possibility of what they could do. I personally think that this is a much easier to read version of 1,3-pentadiene. Remember, you're just looking at the parent chain, looking at the number, you're numbering it left to right is usually what you do when you're going in reverse. You're going to put the branches or the double or triple bonds in, and then you're going to make sure that everything is filled in with hydrogens. All right, so let's look at this example. We have 2,2,4-trimethylpentane. All right, the information that they're giving us is we have an ane ending. That means it is all single bonds. We have a pent carbon group, so that's a 5-carbon group. And we have some branches. We have 3 methyls. Okay, and they are on positions 2, 2, and 4. So let's start with our carbon chain. So we have a pentane. So 1, 2, 3, 4, 5. And they're all single bonds because we have an ane ending. We're going to go ahead and just, because we're going in reverse, we're going to number the carbons. And I'm doing this on the screen for you, but you could just recognize that that's where they are and you wouldn't have to actually write it in. This is just to help you follow along. So going in order, we're going to have on carbon 2, and carbon 4, we're going to have methyl groups. Now remember, methyl groups are single carbon branches. So we're going to have 2 of those on carbon 2 and 1 on carbon 4. So we have our 2,2,4-trimethyl. So there's 3 methyl groups there on the carbon 2, and carbon 4. And then we're going to finish filling everything in with H's. So wherever we don't have 4 things touching our carbon, we're going to add hydrogens. Some books will just not show them, and sometimes they write them in, sometimes they don't. But for the sake of learning, I'm going to go ahead and write in all these H's. And now I'm going to take and I'm going to condense this for you. So we have CH3. We have a carbon here with 2 CH3s attached. We have a CH2. We have a carbon with a hydrogen and a methyl group. And we also, if here, I'm going to turn on my pointer, we have this carbon taken care of right now, but we have this other carbon over here, so we could actually put this in parentheses and have 2 of them. If you will, think of it as 2 branches. We have this branch right here, and we have a branch right there. So you might see it that way. There might be a different way of writing it, but this is probably the easiest. So just taking apart the word, looking at the length of the chain, the types of bonds, and the branches should be pretty simple.